Okay, this is lesson number 54, Algebra 1, Substitution, Axioms, Simultaneous Equations, Solving Simultaneous Equations by Substitution. Okay, the key thing that we're going to look at here is the solving simultaneous equations by substitution. The substitution axiom, yes, it's important, but it's something that you already know how to do, and we'll just kind of go over that when we're solving by substitution. And one of the things that I want you to know is that when you have two equations, such as 2x minus 1 or y equals 1, and x equals negative 3y plus 11. Alright, and if I put a little brace around it like that, that makes it what is called a system of equations. A system of equations means that you look at both of these equations at the same time. So, what we're looking at is that a number that makes this top statement true for x and y. So let's say, for instance, we put a 3 in for x and a 5 in for y. This would be 6 minus 5, and that equals 1. So in this particular problem, my x is 3 and my y equals 5, right? Alright, so if I have what is called a system of equations, that means that that number that works for the first equation will also work for the second equation. And what happens is when we graph those two equations, we get a line for each one. So let's say, for instance, that's the line we get for the first equation. And let's do this one in red. Let's say that's the line we get for the second equation. This point right there where they intersect will be the point that has the same x value and y value for each one of these. So let's say that we had our graph like this. Okay? And this is 1, 2, 3, 4, 5. Let's make this change a little bit. Let's make it. Okay. So we're going to look at it as if 3, 5 is the answer. That's really not the answer to both of these, but let's pretend that it is. That means they cross at 3, 5. That means what they have common with each other is the point 3, 5. Over 3, up 5. Alright, so what we're going to do is we're going to look at two equations, find out what number works for both of these for x, and what number works for both of these for y. And those two numbers, the one that's x and the one that's y, is where our two lines will cross each other. Alright? So, let's go ahead and try a couple of them to practice, and hopefully that'll clear some confusion up if you have any. Okay, so here is the first example, 54.1 on the bottom of page 219. And notice they give us two equations here, and I've got my little brace here, and that tells us that these two are going to be simultaneous or together. So what we're trying to do is we're trying to solve for x and we're trying to solve for y. One of the important things as far as solving for x and y is you can't solve for two variables unless you have two equations. So if I just had 2x minus y equals 1, it would be impossible for me to solve for the x and the y. Two variables, two equations. If I had three variables, if I had an x, y, and a z, I'd need three equations in order to solve these. But since I have two variables, I have to have two equations. Alright, so let's see what I've got. I've got a 2x minus y equals 1. Well, this bottom one here says that x equals negative 3y plus 11. So that means whenever I see an x in any of these equations, I can put a negative 3y plus 11 in there because x equals that. So what that does on my top equation here is instead of the x right here, I am going to put negative 3y plus 11 in its place since it equals that. And I always put it in parentheses. And then that's minus y equals 1. So notice all I did is I put this in for x here, and it showed up right there. Now look at this one equation. I have one equation. How many variables do I have? I have one variable. So I have one equation and one variable. That means I can solve for my y now. So I'm going to distribute negative 6y plus 22 minus y equals 1. I'm going to combine these two. Negative 6y minus y is the same as negative 7y plus 22 equals 1. Then I subtract 22 from both sides, and I get negative 7y equals negative 21. Divide by negative 7, divide by negative 7. That goes away. And I have y equals negative 21 over negative 7, which is positive 3. So I just found my y value. But one thing that's important to understand here is in my original equation up here, this black here, I am looking for an x and a y. I found the y. So what I have to do is I need to take this y and I can plug it into this equation or this equation to find my x. So because of that, let's go ahead and do both. So y equals 3. I'm going to erase all this red here. And let's erase the blue here. And we had y equals 3, right? Alright, so let's plug 3 into this equation. So that gives me 2x equals, I'm going to add 3 to both sides, so that'll give me 4. X equals 4 divided by 2 is 2. Alright, so I plugged it in there. Now I found both of these variables here. X is 2 and y is 3. Now let's plug the 3 into this one. So x equals negative 9 plus 11. Negative 9 plus 11 is 2. So when y is 3, in the first equation, x is 2. When we plugged it in the second one, x is 2. So it doesn't matter which equation you plug y equals 3 into. You'll find your x value. It has to be the same number. Because what we did is we found out where these two equations cross each other. So again, if we were to graph these, and one equation looked like this and the other one looked like that, they would cross at x equals 2, y equals 3. So 1, 2, 1, 2, 3. That point right there is where they intersect. The number that works for both the first equation and the second equation, which in this case was the numbers 2 and 3. Alright, so that's in a lot of detail going over that example. Let's cruise through this next one a little bit quicker. Okay, this is example 54.2, and notice we have two equations, two variables, and also notice that we have an equation here with an x and a y, but down here we're saying y equals x minus 6. So what that means is, when we look at this equation here, we can, whenever we come across a y, we're going to substitute it with x minus 6, and that gets rid of this y here. So we have 2x plus 3, and we're going to put, instead of y, we're going to put x minus 6. And one of the things that you want to get in the substitution situation is you want to get to the point where you can do these without too much struggle, because you will be doing these in elementary algebra, intermediate algebra, algebra 2, college algebra, trigonometry. I mean, it goes on and on and on. It's not something that's going to go away. So don't just think, oh, well, if I don't get this, it's okay because there's not that much on this and I'll probably never use it again. Yes, you will use it. You will use it forever and ever. Okay, so let's go ahead and distribute the 3 times x and the 3 times negative 6. Okay, we're going to combine those. We're going to add 18 to both sides. And we get 5x. That goes away. Negative 13 plus 18 is a positive 5. Divide by 5, divide by 5. And we get x equals 5 over 5, or 1. Alright, so I found out what the x is, but I don't know what the y is. So what I'm going to do is I'm going to take this x and put in here. So y is going to equal whatever x is minus 6. So y equals negative 5. Okay, so your answer will look this way. You'll make a little parenthesis there. You'll put 1 there from here, and then you'll put negative 5 in there. So your answer is 1, negative 5. Now we could have taken this 1 here and put it in here, but it's going to be a little bit more work. It was a lot easier to put it in here and solve it this way. But either one of those equations will work just fine. Alright, so I'm going to do, looks like 3 more examples here, and I'll do those on the next video.